Okay, so what we're going to look at next are two important inverse functions. They are natural log of x and e of x. So e of x is an exponential function, base e. If you haven't heard about exponential functions in the last 24 hours, you probably have not clicked on any television, social media, anything. So exponential functions, that's a base e. And the inverse operation of that is the natural log of x. Um, Technically, you've learned these. The natural log of x, we'll talk about each of these in more detail later about when we find their derivatives and we integrate, but you've been learning about natural log of x for a long time. Its actual definition comes from calculus, so it wasn't really around until calculus was around. But today we're going to look at just how they go together, so that they are inverse functions. We talked about this in the last video. Um, X and Y are switched, so 0, 1 on e to the x is 1, 0. Here, there's a horizontal asymptote. It doesn't, like the domain is all reals, but the range is not. Here, the range is all reals for natural log, but the domain is not. So that's what they look like. You know, I could change this to e to the negative x. Maybe I can. That just means it goes downward. If you make it negative natural log, it switches its position as well. So the same kind of transformations go with them. So today, again, we're not going to do any calculus with these. I'm just going to review some pre-calc and algebra 2 stuff with natural log and e. So let's start with natural log. Logarithms were a part of algebra 2 and of pre-calculus. Natural log just means log base e of x. We write that as the natural log of x. On your calculator, they go together. They're inverse operations on your calculator as well. That's why they're listed like that. So if you have, let's start with natural log. One of the things that we talked about in pre-calc and in algebra 2 is like if you have 3 natural log of x minus the natural log of 2x minus 1. And one of your jobs in algebra 2 and pre-calc was to condense this, to make this smaller into one natural log. So there's some properties, and you'll see me use these properties. I'm not going to go through them, like write them all down with their definitions. You'll see me kind of go through them in this whole unit. So if you remember, a power in front of a logarithm actually, or this number in front, this coefficient actually is the power. So this is the same as saying the natural log of x cubed. And it works both ways. That means this 3 can come in front and be a coefficient of the whole natural log, or it can be a power minus the natural log of 2x minus 1. And then, so that's called the power rule. And then I can also use a different rule called the quotient rule. So I can condense this, make it smaller into one natural log. It would be x cubed divided by 2x minus 1. So there's a quotient rule that says when you're subtracting, you can make those into a division. We called it condensing and expanding. So if you started with something that was condensed, let's say the natural log of 2x plus 1 over x minus 3, because when we take derivatives, it's going to be easier if you expand. So this is called condensed because it's one natural log. So I could expand this. This is a division. So subtracting and division go together. So it's the natural log of 2x plus 1 minus the natural log of x minus 3. And that's all I can do because there's no powers. So this is expanding here, and this is condensing here. Let's just try one with I don't know, natural log of x plus 1 plus 1 half natural log of 3x minus 4. So first of all, this 1 half right here, that can become a power because it's in front of a natural log. So this could be the natural log of x plus 1 plus the natural log of 3x minus 4 to the 1 half power, which we work with a lot in calculus. And then adding goes with multiplying. So to condense this into one logarithm, it would be the natural log of x plus 1 times, I'm going to just write it as the square root of 3x minus 4. So that's how I would condense that. So that's something with natural logs. And that's something that we use. So that's a little refresher of those properties. The other thing that we use with e and natural log is how they go together. So for example, if I have e to the natural log of x equals 4, can you solve for x? So this is basic equations, exponential equations. Well, if you remember, e and natural log are inverses. So these two actually cancel each other out, and I just get x equals 4. A little bit more difficult if I had like e to the x equals 12. I have an exponent that is a variable, and I have base e. So what I can do is I take the natural log of both sides because I'm doing the inverse operation. The inverse of e is natural log. So then this x becomes a coefficient. So I get x natural log of e equals natural log of 12. Because these two are inverses, up there I said they cancel. Technically they become 1. When I say cancel, I mean 1. So natural log of e is 1. If you don't believe me, put it in your calculator. So x equals the natural log of 12. I don't know what that number is because I don't have a calculator like normal. This is an acceptable answer because that's the most simplified answer. Natural logs are mostly irrational numbers, so it's some irrational number. You could type that in your calculator. You could type in the natural log 12 and you get whatever decimal approximation that is. In order to use that, like if you started with 4 plus e to the x equals 6, before you take the natural log, you need to isolate your function in terms of e. So you'd want to move your 4 over first. So then you'd have like e to the x equals 2, stuff like that. Other way around, let's say you have the natural log of 4x equals 1. So how would that work? Well, I have my natural log isolated all by itself. What is the inverse operation of natural log? It's e. So you say e to the natural log of 4x equals e to the first, so just e. And then again, I know that if I take e to the natural log, these cancel, or they're equal to 1, and that 4x can come in front, so it's 4x equals e to the first, so x equals e divided by 4. Again, I would leave my answer like that, but you can definitely type that in your calculator and get the decimal approximation. A little bit harder problem if you had the natural log of the square root of x plus 2 equals 1. Before I did this one, I would probably rewrite this as the natural log, I'd put the 1/2 in front. So 1/2 natural log of the quantity x plus 2, because the square root is 1/2 power, the power can go in front. So then I could multiply by 2, so then I'd get the natural log of x plus 2 equals 2. Now my natural log is more isolated, so I can use e. So I get e to the second here. These cancel, I get x plus 2. So x equals e to the second minus 2, whatever that answer is. Okay, so it's kind of a rundown of e and natural log and how they are used. And like I said, this should be a review. So I didn't go into a lot of detail because this is something that is taught in Algebra 2 and in pre-calculus. So make sure you are doing the assignment. I'm going to hit pause and check the assignment and make sure I said everything that you needed for. Okay, so one other thing, when we're talking about inverses, just to make sure, this goes back to the previous assignment as well. If you have y equals the natural log of 3x, and I want you to find the inverse of that function. Remember, f to the negative 1 of x is that inverse. To do that, we switch x and y. So x equals natural log of 3y. And then we could solve for y. To do that, the inverse operation of natural log is e. So I'd have e to the x equals e to the natural log of 3y. Again, these cancel, become 1. They're inverses. So 3y equals e to the x. So y equals e to the x divided by 3. So the inverse would be e to the x over 3. So I think with that, that's kind of a review of of Algebra 2 and Pre-Calc E and Natural Log in about 10 minutes. There's an assignment on Canvas. There's one answer where they left 6 over 10. Remember, I would have probably simplified it. You'll see which one I'm talking about, but you'll figure that out. So do the assignment on Canvas. Again, this is a review, but if you have questions, please email me. I don't know, through Canvas, through Outlook. I don't get a hold of me because I'm just here to answer questions and I want to finish the year out strong and I want to make sure everybody gets their credit. So, all right.